Section 8.3 is on multiplying polynomials. To multiply two polynomials, each term in the first polynomial must be multiplied by each term in the second polynomial. To do this, we're going to use the distributive property. But there is a little shortcut you can use, or actually a little trick you can use when you're multiplying two binomials. So two polynomials and each only has two terms. We can use the FOIL method. You'll want to multiply the first terms, the outer terms, the inner terms, and the last terms, and then add them all together. This works. It's a nice little trick because it tells you the order in which to multiply, although order doesn't really matter when you're multiplying. But this way you make sure that you don't forget to multiply any terms by each other. So let's take a look at a couple examples, and we'll use the FOIL method. Okay, so find each product. X plus 3 times x minus 4. So these are two binomials. X plus 3 is a binomial because it has two terms. X minus 4 is a binomial because it has two terms. So when we multiply, we're going to use the FOIL method. So I'm going to multiply my first terms times each other. So x times x is going to give me, I'll put an F here to tell you that's the first. X times x is going to give me an x squared. So the first term in each set of parentheses. The outer terms, so I'm going to multiply these guys here, my outside terms. So x times negative 4. My outer terms are x times a negative 4, which is going to give me a negative 4x. My inner terms are the two that are on the inside, so 3 times x. And that's going to give me a 3x. And then my last terms, the last term in each set of parentheses, so that would be 3 times negative 4. And that's going to give me a negative 12. Okay. So I have, when I FOIL, I have x squared minus 4x plus 3x minus 12. To come up with my final answer, I need to combine any like terms that I have, and I notice that these guys here in the middle are like terms, so my final answer is going to be x squared. Negative 4x plus 3x gives me a negative 1x, or just negative x, minus 12. So the product of x plus 3 and x minus 4 is x squared minus x minus 12. And to do that, we kind of did the distributive property multiple times, but used FOIL to help us make sure that we got everything multiplied by each other. Let's take a look at another example here. I have 2x minus 7 times x plus 5. And I'm not going to write out each one this time. I'll just go ahead and do my first, outer, inner, last. So my first terms is going to be 2x times an x, which gives me a 2x squared. My outer terms for O, 2x times 5 is going to give me a 10x. My inner terms, negative 7 times x is going to give me a negative 7x. And then my last terms, negative 7 times a positive 5 is a negative 35. And again, I have some like terms in the middle here that I can combine. So I'll have 2x squared plus 3x minus 35. So you don't have to, if you've done this before, or if you're finding it pretty easy to remember FOIL, you don't have to write down, F is 2x times x, and O is 2x times 5. If you can just do that, draw the little lines, that's very helpful. Also remember that you cannot combine 2x squared with 3x. You can only add or subtract monomials that have exactly the same variables raised to exactly the same powers. 2x squared has an x squared, 3x has an x, so those cannot be combined by addition or subtraction. Let's try an example here that has more than one variable in it. So I have 5x minus 3y times 2x minus y. I'm going to use the FOIL method again, multiply my first terms. 5x times 2x is a 10x squared. My outer terms, 5x times a negative y is a negative 5xy. My inner terms, negative 3y times 2x is a negative 6xy. And notice, even though the y came first in this term and then we had an x, so it was kind of like y times x, I could have written this as negative 6yx, But I like to keep my variables in alphabetical order, and actually these two here are going to be like terms. It doesn't matter if I write it xy or yx. They both have an x to the 1 and a y to the 1. And then I have my last, negative 3y times a negative y is going to give me a positive 3y squared. And as I just said a little bit ago, I do have some like terms in the middle here. So my final answer is 10x squared minus 11xy plus 3y squared. And let's do this example here. So this is a little more tricky. So I have the quantity 3x plus 2, the whole thing squared. Now the temptation is just to say, kind of distribute this exponent of 2 and say it's going to be 3x squared and 2 squared, but that's not really what's going on. You really need to write this out as two binomials. It's 3x plus 2 times another 3x plus 2. Don't just distribute the exponent. Write it out as two binomials. Now we can use the FOIL method. First, 3x times 3x is 9x squared. Outer, 3x times 2 is 6x. Inner, 2 times 3x is another 6x. And last, 2 times 2 is 4. Combining my like terms, again I have 2 in the middle. 9x squared plus 12x plus 4. And we can also multiply larger polynomials. That is not just two binomials, but we can multiply, as we have in this case here, a binomial times a trinomial. You can also do a trinomial times another trinomial, or even larger polynomials. So we're going to, again, just use the distributive property. In this case, FOIL doesn't work. FOIL only works if you have two terms in your first polynomial and two terms in your second polynomial. This is kind of like the distributive property gone wild. So I need to take this 3x and multiply it by each term in the second polynomial. And I think I'll do that first. So 3x times 2x squared is going to give me 6x to the third. 3x times 7x is going to give me a positive 21x squared. And then 3x times negative 8 is going to give me a negative 24x. So that was distributing the distributing the 3x to each term in the polynomial. Now I need to distribute a negative 5. Okay, don't distribute just a 5, make it a negative 5. And now distribute that to each term in the second polynomial. So negative 5 times 2x squared is going to give me a negative 10x squared. Negative 5 times 7x gives me a negative 35x. And negative 5 times negative 8 gives me a positive 40. Now I just need to make sure that I'm combining all of my like terms. So I have one term that's x cubed. I have two terms that have an x squared in them. And I also have two terms that have just a plain old x in them. And I have a 40 that's all by itself. So my final answer is going to be 6x cubed. And now combining my purple ones, 21 minus 10 is a positive 11x squared. Looking at my green ones, negative 24x minus 35x gives me a negative 59x, and then plus 40. So in order to multiply polynomials, basically you just use the distributive property, but it's important to keep track that everything in the first polynomial gets multiplied by everything in the second polynomial.